We're going to be looking at alcohols and phenols in this chapter, but the first thing we're going to do in the chapter is learn how to name alcohols. Alcohols and phenols are very related in that they both have what we would call a hydroxyl group, but the difference is alcohols all have sp3 carbons and phenols all have that hydroxyl group connected to a carbon in a benzene ring. So if we look right here, the alcohol right here, that carbon is sp3, phenol has a benzene ring on what looks like an alcohol group. There are things called enols in which they have both an alkene and an ol on it. Right here we're showing an enol where there's the ol is on the ene, and these are a special group that we're going to look at next semester, except for recognizing them at this point in time. Now, alcohols can be classified. These are alcohols other than phenols. We don't really call phenols alcohols. You can call it an alcohol when you're considering it as being a protic hydroxyl group, but other than that, we really don't call phenols alcohols. Alcohols can be classified according to the type carbon that it has. And if we look at a primary carbon, it's going to be an alcohol that is on the end of a chain. So that carbon on the end of a chain only has one carbon attached to it. The rest of them are hydrogens. With a secondary alcohol, you have two carbons attached to the carbon, and with a tertiary alcohol, there are three. And this is rather reminiscent of looking at carbons and hydrogens that we've seen so far, where we say, oh, this is a tertiary carbon, etc. We're just looking to see what does the carbon look like that the alcohol group is attached to. Is it primary, secondary, or tertiary? To name an alcohol, what we always do is we find the longest chain with the functional group in it. Now remember, if you have more than one functional group, to make sure that the longest chain has both of them in it. And you give priority if you have both an ene and an ol in there, and they are at the same distance from the end of a chain. The ol is going to get the priority, not the ene. Now, when we go to name an alcohol, for instance, on a 5-carbon chain, we would take the E off the pentane and replace that with ol, and then you would have pentanol. So the other thing that we have to do is make sure that we number where the functional group is. This is just all the same things that we've done in previous nomenclatures. You number the substituents according to the position on the chain, listing them in alphabetical order, and remember to have the same numbering system for the substituents as you have for the functional groups. Okay, so let's look at some examples here. If we look at this one on the left, you will see the longest chain is 5 carbons. So with 5 carbons, we're going to say pent. And then the functional group is ol, so we say pentanol. We will say 2-pentanol because the ol is on the number 2 carbon. And because the methyl is also on that number 2 carbon, we call it 2-methyl 2-pentanol. There is another way that we can name this, and both ways of naming it are acceptable. You can put your number just before the functional group, so that we say, instead of 2-methyl 2-pentanol, we can say 2-methyl pentane 2-ol, or pentan 2-ol. If I look at the second compound, you can see it's cyclohexanol, except there's 2 ols, so we say cyclohexane diol. Whenever we have the diols, we just name the alkane and put diol at the end. So a diol on a pentane would be pentane diol. Now you can see that these are cis, so you would name them 1,4-cyclohexane diol, but put a cis in front of it. If we go to this third compound, what do we see here? The longest chain is actually 4 carbons, see that? okay? And if we look at the functional group, it's all, so we have to give it the lowest numbers. So it's 2-butanol, and this is a substituent. So this substituent is called phenol, so it's 3-phenyl 2-butanol. And of course, on this you can put the 2 before the all, or here you can put the 1,4 before the diol. Those are alternative ways of putting your numbers into the name. There are some common alcohols, for instance, benzyl alcohol, allyl alcohol, tert-butyl alcohol, ethylene glycol, and then right here we have glycerol. Notice the systematic names would be phenylmethanol. This is where the functional group is, so that would be methanol. There's a phenyl stuck on the methanol. This is an enol, so we name it as an enol. It's 3 carbons, so it's propanol. Where's the alcohol? On the number 1 carbon. Where's the ene? On the number 2 carbon. Remember, the alcohol gets priority in numbering. This one would be 2-methyl-2-propanol. Here's 1,2-ethane diol. And then this would be 1,2,3-propane triol. And you can have tetraols and pentols and things like that. They're not quite very common, but those are also possible. Here are some examples we can go through. This first one, we have to find the longest chain. The longest chain is 7, right here. That's heptane. The functional group is all, so it's heptanol. Where is the all? On the number 3 carbon, so it's 3-heptanol, or we could say heptan 3-ol. Then we name the substituents. On the 3 carbon, there is a methyl, and on the 5 carbon, we have an amino group. So this is 5-amino, 3-methyl, 3-heptanol. If I go down here to this lower one, I can see there are 8 in the ring, so it's a cyclooctane. There's 2 alls, so it's a cyclooctane diol. Where are they located? 1, 2. So it's 1,2 cyclooctane diol. Alternatively, we could say cyclooctane 1,2 diol. When you have enols, you have both an ene and an all functional group. Remember to get them all in the longest chain. The alcohol group has the higher priority. So if you look, if I count from this end, the ene's on number 2. If I count from this end, the all is on number 2. What do I choose to do? I give the all higher priority. So this is going to be a 2-all and a 4-ene. And so we call it a 4-hexene 2-all. Or you could say hex 4-ene 2-all. Go ahead and name these. The first one is a propane triol. What do you have to do? You have to name it 1,2,3 propane triol. The common name for this is glycerol. This is an important compound to know when you start into biochemistry. You're going to find that it's important in understanding fat and basically lipid chemistry. If we look at this next compound, find the longest chain. There's 5. 5 carbons gives you pentanol. Where's the all? On the number 3 carbon. So it's 3-pentanol, or you could say pentan 3-ol. But we've got a substituent of the amino, and so we're going to put that on the number 1 carbon. So it's 1-amino, 3-pentanol. Go ahead and draw 1-phenyl cyclopentanol. First thing you would do is you would draw a cyclopentane ring, and on it put an all group. Then on the number 1 carbon, which is where the all group is, you would put a phenyl group. So this is what you should have drawn. Here is a cyclopentane all, and on the number 1 carbon where the all is, you have a phenyl group. Go ahead and draw 2-methyl 4-pentene 1-ol. To do this compound, the first thing you would do is draw a pentane, so a 5-carbon chain. On the number 1 group, you would put an all, and on the number 4 carbon, you would put the ene. Then number 2, there would be a methyl. So here we go, 1, 2, 3, 4, 5. The all on number 1, the ene on number 4, and the methyl on the number 2. Go ahead and name this first compound right here, and then start the lecture again to check your answer. Okay, if I look at this compound, I can see the longest chain has 3 carbons in it, the longest chain with the alcohol. So this is a propanol. Where's the all group? On the number 1 carbon. So it's a 1-propanol. Then we look and see there's a substituent of a phenyl group on it. So this is 1-phenyl, 1-propanol. Then I see that it's chiral. So I'm going to say 1, 2, 3 is the priorities. That's counterclockwise and the hydrogen is back, so it is S. Now name this compound. To name this compound, I see that it is a cyclohexene and a diol. So my longest chain is a cyclohexene diol. Where are those groups? Well, one of these is 1 and one of these is 4. So this is 1, 2, 3, 4. So it's going to be 2-cyclohexene, 1,4-diol. And then, even though you might think this is chiral because it looks like you have 2 chiral, well, you do have 2 chiral atoms. The compound is not chiral because it's a meso compound. See the symmetry that you have, the plane of symmetry between these 2 halves of the molecule. So you don't have to name this R or S. What you would just say is cis 2-cyclohexene.